All right, let's look at another problem for this parametric equation of lines. Remember, the general form for the parametric equation of lines that is written in this vector form is given by this. And here a point P is on the line, and then this vector V is so-called the projection vector the line is pointing at. Okay, so if we want to think about a specific example, just like the one that we just worked out in last section, 2 plus 4t, 5 plus 2t, and 3 plus 5t. And how do we understand this formulation? I think that is critical because over here, we know that for each t value between negative infinity and positive infinity, then we get 1 point. Okay, that point is on the line, and also that point is having the coordinate in the xyz. So what if we really want to? We should write this as x of t and y of t, z of t, and here obviously x of t is 2 plus 4t, y of t is 5 plus 2t, and z of t is 3 plus 5t. And we can also think of some specific value. For example, if you let t equal 0, what do we get? We get x of 0 to be 2, and y of 0 to be 5, and z of 0 to be 3. So at t equals 0, we got the position vector r0, which has the component 2, 5, 3. Do we see where the 2, 5, 3 come from? This is indeed the OP vector, where the point P is given in this question above, right? And so note, when you want to note, this is OP vector, and the P point is having the coordinate 2, 5, 3. So when we try to understand this mathematical formulation in the vector form, we better link it to the point in space, and you make sure that we can connect the coordinate of the point to this formulation. For example, when we let t equals 1, so what is x of 1 is? So it's 6, right? Y of 1 is 7, I think. And z of 1 is 8. So obviously, this r of 1 is 6, 7, 8, and this is the point. This is the vector OQ, and the Q is having the coordinate. The point Q is having the coordinate 6, 7, 8, which is given in the question box. Okay, so those are the discussion of how we understand this mathematical formulation for the parametric equation line in the so-called vector form. Now we can use this concept and particularly this formula to discuss problem that we would usually ask about some geometric discussion. So over here, so how can we find the intersection of two lines? Okay, for example, the first line is given by this parametric equation, and the second line is this, and obviously here we use two different parameters, t and s, but they're still just a parameter. We want to distinguish the letter just because we don't want to get confused about those two equations. Okay, so we do know in three-dimensional space, two lines may not intersect, but the question is asked here. It asks us to find the point of the intersection. And how do we do that? Well, let's think about it. The point of intersection will have a set of three coordinates, right? So if there is such a point, then we could just try to find. So if this exists, that is a hint. If this exists, it has to be both R1 and R2. Both R1 and R2, which means we can set the value for T and S such that this R1T and R2S equal to each other in terms of X, Y, Z components. So this is our logic in the discussion. So what we should do is to remember, well, maybe we should first simplify this notation. What is R1 of T? It is this one, but we better make it a simple one vector, which is 1 minus 3t and a 0 plus 0t and 0 plus 0t again. And this is our R1 of t. And we should note this is x of t, this is y of t, and this is z of t. And also we have R2 of s because it is using the s as the parameter. R2 of s is 0 plus 2x and 1 plus 0. So it's just 1, I guess. And then the third component is 1 plus s. So here, this is x of s. This is the y of s. And this is z of s. By choosing different value for t, we got the R1 of t, which are having three components for x, y, z. And similarly, by choosing different value for s, we get R2 of s, and we will get different coordinates x of s, and y of s, z of s. So now, here, this is our target. We want to find this point with the coordinate x, t, x, y, z, and those x, y, z should be matched by R1, R2 if those R1, R2 are intersecting. Okay, so what is R1 of t? It is 1 minus 3t. Okay, what is the R2 of s? Well, it is 2s, I think. Okay, and then for the y value, we want to find the yt, which is 0. And we need to also find y fast, which is 1. That is really strange. So we better have a question mark on each of those equal sign, otherwise we're in trouble. So for the third component z, if those two lines are intersecting, we will have a z coordinate from the R1 and R2 match each other. This is the 1 plus x. Okay, so the big problem is this one. Cannot happen. So this cannot happen. So how do we answer this question? The answer will be there is no, maybe we should use a different color. There is no intersection for these two lines. So this is our answer. Okay, so this is interesting problem. Hopefully you have a sense. How do we understand this by using mathematical formula to discuss the geometric relationship? It is all here. Okay, so the key is this. But now let's modify the question a little bit to see what is the question. Find the intersection of two lines. Now let's just give those lines equation directly. So this is a 1 minus 3t 1 0, and then the second line equation is given by 2s 1 and plus 1 plus s. So how do we answer this question? It is very similar. We still try to get the point xyz. Suppose the point of intersection is xyz, the point P, suppose. Okay, and if there is such point P, then the R1 on the left and R2 on the right should match each other at with some choice of T and S value. So if that is happening, we should be seeing that on the left we have this, on the right, on the left of the equation, right of the equation about x, y, z, we have those. So this is 1 minus 3t. This is a 2s, and those are the two components for the x coordinate. And for the y, we have 1 on the left of the equation. On the right of the equation, we also have 1. Okay. And on the left equation for z, we got a 0 from R1t. Okay. And on the right hand side, we have 1 plus. Okay. Then the question is becoming, can we find t and s such that 1, 2, 3, 1, 2, 3 are true at the same time, are valid at the same time? The answer is maybe we should just solve it, right? Because from the third equation, we know 1 plus s equals 0, so s 1 plus s equals 0, so s equals -1. And then we put it back into the first equation. We know 1 minus 3t equals 2 times s. Now s is -1. So we got what? We got now we can add a 2 to both sides. Plus 2 plus 2, because right hand side is -2, and then add 2, it becomes 0, and then we got what? We got 3 minus 3t equals 0, so t equals 1 then. Okay, so now we can see by setting, now we see by setting t equals 1 in R1 of t, and s equals -1 in R2 of s, we get R1 of 1, which is R1 of 1, which is 1 minus 3 times 1, and then 1, 0, which is -2, 1, 0. So remember, this is the position vector. By having the tail to be at the origin, and the head is at the point -2, 1, 0. So -2, 1, 0, no. Point, we use the parentheses, -2, 1, 0 is on R1, the line. Okay, and similarly, R2 of -1, which has -2, 1, 0. Note the point -2, 1, 0 is on R2. So obviously, those two points are just the 1 point, and so the 2 lines R1, R2 are intersecting at this particular point. Okay, so let's stop for a moment.